Okay, so this will be our first lecture for Math 112. Lecture 1 is about graphs. And in this lecture, we'll plot some points in the coordinate plane. We'll plot some equations by plotting some points, introduce x-intercepts and y-intercepts and Geogebra, which is a very useful online calculator. And we'll learn about reading graphs. So basic idea, here's the plane, right? We have our x-axis, that's this. And our y-axis. I want to be able to plot points. So the point 2, 1, the first number is your x, and your second number is your y. So we go to x equals 2. It's 2 on the x-axis, 1 on the y-axis, that's here, and we plot that point. All right, the point -1, -1. That means x is the first number, that's -1. Y is the second number, that's also -1. So on the x-axis, we look for -1, that's here. On the y-axis, we look for -1, that's there. And where these two lines intersect, that gives us a point -1, -1. So there is the point -1, -1. So two numbers, first one's the x-coordinate, second one is the y-coordinate. Okay, so if you have a formula, you can plot the graph of a formula by starting with your x and you determine your y values from that. So y equals absolute value of x. Recall that the absolute value of a number is technically the number itself if the number is positive, the negative of the number if the number is negative. So absolute value of -3, well, we look over here and we say -3 is less than 0. So we use this formula, -3 equals -3, which is equal to 3. Right, and so the effect of the minus sign here on a negative number is just to get rid of that minus sign. So the absolute value of -3 is just 3. And so absolute value of when we plug in -3 in for x here, what do we get? We get 3 minus 1, and that's 2. So it gives me an x value and a y value. So if y equals -2 minus 1, so that's saying the x value is -2, we plug that in there. What's that going to be? That'll be 2, because the absolute value of -2 is just 2 minus 1, and that's 1. So this is 1. Absolute value of -1 is 1, 1 minus 1 is 0. Absolute value of 0 is 0, 0 minus 1 is -1. Absolute value of 1, well, if we take a positive number, the absolute value of number is just the number itself. So absolute value of 1 is just 1, 1 minus 1 is 0. Absolute value of 2 is 2, 2 minus 1 is 1. Absolute value of 3 is 3, 3 minus 1 gives me 2. And so there are our x and y coordinates. This is a bunch of points. So I'll scroll down a little bit. What were the points that we had? We had the point x -3, y is 2, x is -2, y is 1, x is -1, y is 0, x is 0, y is 1. Oh, -1. X is 1, y is 0, x is 2, y was 1, and x is 3, and y is 2, right? And those are the same numbers we have here, an x-coordinate and a y-coordinate. So we can plot all these points because they're all just points in the plane. So the first one is x is -3. So these are my x's, these are my y's. X is -3, y is 2, so that's up here. X is -2, y is 1, so that's there. -1, 0. X is -1, y is 0. X is 0, that means here, and y is -1, so that's down there. X is 1, y is 0, that means you're right on the x-axis. X is 2, y is 1, that's up here, and then 3, 2. So everything sort of is going to look the same, more or less. And we can draw in our graph. That's the usual absolute value looking graph. Put little arrows on it like that. And the arrows here and here. The graph just keeps going in that direction. It doesn't do anything goofy. It doesn't start waving around or anything. Okay, one of the questions that we have in the next question is the point minus 5, 5 on the graph? So we'll answer that question. If I put in, we'll put a little dash line here, minus 5 is the y value that we want to get here equal to 5. And you can't tell right now because the graph stops, right? The graph doesn't go all the way up here. So, oh, that's just 5. Sorry about that. There should just be a plus 5. Is this number 5, right? Should this be a 5 in there? Well, we know that the equation is y equals absolute value of x minus 1. So is the point 5, 5 on the graph? Well, we'll plug in a 5 for y. That's this 5. We'll plug in a 5 for x. Leave a little question mark there because we don't know whether or not we're going to get something true or not. And this equation becomes 5 equals question mark 4 because absolute value of 5 minus 1 is 4. Is this equation true? False. So 5, 5 is not on the graph. So we can check really what this number should be according to the formula. It should be 4. The 0.54 is actually on the graph. What are the x-intercepts? So the x-intercepts, that's this definition, is where graph intersects x-axis. And intersects means it just meets it. Doesn't necessarily have to go through it, but here it does. So these are my two x-intercepts. That's where the graph meets the x-axis. And we can write things in two different ways. We can write it as x is minus 1, y is 0, and 1, 0, right? Write them as full points. Or x equals minus 1 and 1, because if we're intersecting the x-axis, right, y is always 0. Y values are 0 if you had an x-intercept. So you don't really need to put in the x-intercept. We just know, we're just interested in what's the x values at the x-intercepts. So the y-intercept it's where the graph intersects the y-axis, right? And this is the y-axis here. So this is our only y-intercept. And that's the point x equals 0, y equals minus 1. Or we can just say that this is y equals minus 1 because every point on the y-axis has an x value of 0. So an x value of 0, y value of minus 1, you can just say y equals minus 1 because we know that the x value is not 0. So a little bit of language, x-intercepts. That's where the graph intersects the horizontal axis, y equals 0. The y-intercepts where the graph intersects the vertical axis. Remember that the vertical axis is x equals 0. And a procedure to tell if a point is on the graph of an equation, plug the point into the equation. If you get something true, it's on the graph. If you get something false, it's not on the graph. And that's what we did here. Is the point 5, 5 on the graph? Well, we plugged in y equals 5, x equals 5. We got 5 equals 4. That's not true. So that tells me that's not on the graph. Okay, so I'm going to introduce a program called Geogebra. If I can figure out, if I can remember how to switch sharing. Here it is. So if you plug in www.geogebra.org, it gets you this, start calculator, and here is the calculator. And you can type in all sorts of things. I'm going to type in a particular function. Oops. Y equals, I'm going to go down here and get the square root sign. Square root of x plus 4 quantity minus 3. And so there is a graph of a function, right? And it's a square root function. And so this is, Geogebra is a very nice graphing calculator. It does all sorts of things. One nice thing is that it does, it allows you to come up with a table of values for your function. You have to tell you where you want to start, where you want to end. So before we do that, we'll say we'll start with x equals minus 6 and go to y equals 6. The default one just does minus 2 to 2. Back to my table of values. We'll edit our x column to start at minus 6 and end at 6. There we go. So a much longer thing. Note a couple things about this. One of the plots, it gives you a little dot for each one of the points that it plotted. So minus 4, minus 3, that's here. Minus 3, minus 2, it's there. Usually if you just click on the space with the graph. Oh, if you go back to algebra. Oh, the point's still there. Okay, so we'll go back to the table. So note that for minus 6 and minus 5, it gives you little question marks up here. So when x equals minus 6, the graph doesn't actually go that far to the left. So there's no y value for x equals to minus 6. Likewise for minus 5, there's no y value there. So if we went back and we plotted x equals minus 6, for example, right? This is all the points with x coordinate minus 6. There's no point on the graph with x coordinate minus 6, so there's no y value. If we go back to our table again, we notice if we say x equals minus 3, then y equals minus 2. And what that means is if we put in the equation x equals minus 3, right? That's this vertical line. It goes through the graph at this point, and that's the point x equals minus 3, y equals minus 2. And our table gets us x equals minus 3, y equals minus 2. What about the x-intercept and the y-intercept? If we look through this, remember that an x-intercept has a y-coordinate of 0. So if we look in the y part of the table, we see that there's a 0 here. That corresponds to x equals 5. And so there's my x-intercept, 5, 0. A y-intercept has an x-coordinate of 0. So if we look through our x's for 0, we get minus 1 as my y-intercept. So that's right there. 0 minus 1, that's my y-intercept. So if you're looking at a table, you want to know where the y-intercept is, find out where the x is 0. If you want to know where the x-intercepts are, look for where the y is 0. And Geogebra is a very useful graphing program. I'll be using it a number of different times, and so you'll see it again. It's very similar to Desmos if you've ever used that. Okay, so we'll go back to our lecture notes. So that was Geogebra, and what we found is to find the x-intercepts from a table, find the zeros in the y column. To find the y-intercepts from the table, find the zeros in the x column. Finally, how do we read a graph? So here's the daily high and low temperatures in Minneapolis, February 2021. And we want to be able to read this graph. So where are x-intercepts? X-intercepts are where the graph touches the x-axis. So for the high, where's my pen? Here it is. You've got an x-intercept here and here. And we'll have an x-intercept here and there, and then no other time. So this is February 5th. This is February 6th here, 7th. So we'll say this is halfway through 6.5, and this is 6, 7, 8 to 7.9. This is the 10th, so this is just the 11th. We'll say 11.1 up the 15th. Right, and so what happened on those days, that's when your high was equal to 0. That's when the temperature hit 0. And note that in between, say, here and here, the high temperature was always below 0 on those days. For the low temperatures, there's an x-intercept there, there's an x-intercept there, and two really quick ones here and here. So the low temperature, say if we say this is day 5.1, this is 15, 16, 17, 17.2. The low temperature was below 0 all the way between these two dates, and then it dipped below 0 a little bit out there. Where are the y-intercepts? The y-intercepts are here, here, and here. What date is that? Well, if this is February 1st, 2nd, 3rd, 4th, 5th, this is sort of February 0th. So this is actually January 31, to interpret that correctly. So x equals 0 corresponds to January 31. And so the temperatures on January 31 range to, I don't know, 29 to 33, it looks like, something like that. So on February 14th, what was the high and the low? This is the 15th, so this is the 14th here. The high, you know the date, the value on the x value, you find the high by looking over here. So on the 14th, it looks like the high was maybe -2. What was the low on the 14th? Well, you know the x value, so you go down to the graph of the low and you go over to the y-axis to say that the low looks like it was -19. So if you got an x value, like the 14th, and you want to know what the y values are, you start at the x value, you go to the graph, and then you look over to the y-axis. On what days is the high temperature 10 degrees? This is actually asking for a y value, right? 10 degrees. We want to know when is the high temperature 10 degrees? Here, and then here, and then we have 2 points there. So 5 on either side of 16 and on either side of 17. The temperature was 10 degrees. So if you know a y value, how do you find the corresponding x values? You went along this horizontal line until you hit the graph, and then you look down. You keep going and make sure you get all the possible places where the values are like that. So to read a graph, start on the x-axis a particular number, go vertically up or down until you hit the graph, and then go horizontally to the y-axis to read off the corresponding number. Right, and that's this procedure from 14. That's my x value. We go down till we get to the y value, to the graph, and then we read off the y value. Okay, so that is that lecture.